Welcome to one and all. Today we are going to see the quantitative techniques in management, among which one small topic which is known as the transportation model or transportation problem. So what is transportation model or problem? It is a typical operational research technique intended to establish a least cost route for the transportation of goods from the sources to the various destinations. A transportation problem is a special type of linear programming problem which can be solved by simplex methods of solving these problems. However, practically an alternate methods called as a transportation methods is used to solve them. What are the terminology used in transportation problem? First, the balanced transportation problem. Here, the total capacity of the supply points or sources is equal to the total demand at the destination. Second, unbalanced transportation problem. Here, the total supply is not equal to the total demand. Third, the transportation table. It is used to represent the data about the supply at sources, demand at destination, and per unit transportation cost from each sources to each destination. Fourth, dummy sources or destination. This is represented by adding an extra row or column to the transportation table with 0 per unit cost for each of its cells. It is used to a balance and unbalanced problem by considering an appropriate supply or demand for it. Fifth, initial feasible solution. It is a solution that satisfies the supply and demand conditions, and yet it may or may not be optimum. One, there are three different methods of obtaining these solutions: vice a north-west corner methods, NWCM, matrix minima or least cost methods, LCM, and Vogel approximation methods, VAM. 6. Optimum solutions. It is a feasible solution which also gives a transportation plan with a minimum total cost. This can be obtained by using stepping stone methods or modified distribution methods, MODI methods, once we get the initial feasible solution. General procedure for solving the transportation problem. Step 1. Define the objective function to be minimized with the constraint imposed on the problem. Step 2. Set up a transportation table with m rows representing the sources and n columns representing the destination, along with their supply and demand figures as well as the unit cost figures in the cells. Add dummy row or column if necessary to balance the problem. Step 3. Develop the initial feasible solutions to the problem using northwest corner methods or least cost methods or VAM methods. Step 4. Examine the feasibility of initial solutions. The solution is feasible if it has the allocation at m plus n minus 1 number of cells at independent possibles, that is, it has the m plus n minus 1 independent occupied cells. Step 5. Test the solution if found feasible for optimality by finding out the opportunity cost for all the unoccupied or empty cells, or non-negativity, that is zero or positive opportunity cost for all the empty cells indicates that the solution is optimum. Step 6. If the solution is not optimal, we improve it by using stepping stone methods or MODI methods. Step 7. Repeat steps 4, 5, 6 until an optimal solution is obtained.